Right, here's a question I'm going to go through as a worked example. It's one where the student carries out 2 experiments to determine the enthalpy change that occurs when an anhydrous sodium carbonate reacts to form hydrated sodium carbonate. It's one that you will do as a required practical. Okay, starting off, we have a look at the main experiment. This is the enthalpy change that's hard to determine. So it's going to be at the top of our sheet. I'm going to write it at the top of my page here to keep us straight. So it's Na2CO3 There you are. Right, so that's our experiment. That's the reaction we can't do. And this is our delta H that we want to find out. Delta H reaction equals question mark. We don't know. And we've been given some information. So first up, it wants you to know about this reaction here. Sodium carbonate adding water to make sodium carbonate solution. So we're dissolving anhydrous sodium carbonate. So the first thing to do here is to work out the enthalpy change there. You've been given information, 50 grams distilled water in a polystyrene cup, temperature has been recorded, and the mixture stirred in the final temperature. So we've got a temperature rise there. So first of all, we know that this is an exothermic reaction, the temperature has gone up. So I'm looking for this experiment to find out Q equals mc delta T. I like to write out what each of the symbols means. So M equals, it's the mass, and there we've been told we've got 50 grams of distilled water, so the mass is 50 grams. C, that is the specific heat capacity, 4.18, and that's in joules per gram per degree C. And then delta T is the change in temperature, and that is 32.4 take away 27.0. So the temperature increase is 5.4. Right, so MC delta T, that's 50 times 4.18 times 5.4. And that works out for us as 1128.6 joules. And I'd like to, now we work out Q in joules, but we do delta H in kilojoules. So delta H equals Q divided by moles. So before I get to using Q in the delta H, I'm going to write it out in kilojoules, so we're ready to go. Okay. Right. I need to know the number of moles. So moles equals mass over mR. Now the most common mistake people make is getting the masses mixed up. The mass here is the mass for water. That M is for the water, because it's about the water in that cup that's been heated. So we've got a cup, we've got a polystyrene cup with a thermometer sitting in it and a lid. The mass I want for Q equals mc delta T is the mass of water. But when I want to know delta H, because delta H is per mole of the substance reacting, then I need to know about the mass of that substance, and it's in the table here, so it's 5.09. So this here, it's going to be 5.09 divided by mR, and it's the mR for sodium carbonate, which works out as 106. And that gives us the moles being 0.048, oops, let's make it fit, 0.04802. So that's my moles. I'm going to pop them into the delta H here. So let's put it all in. 1.1286 divided by 0.04802. And that one works out 1.12. That one works out as 23.5. So that is delta H, and that's in kilojoules per mole minus 1. Now, I'd like to show you where that fits on the diagram above. So let's take another colour. Now this diagram above, we said we needed to do 2 experiments, and this is the first one. And this is the sodium carbonate with lots of water making the sodium carbonate. So it's Na2CO3AQ. That's what goes at the bottom here. We've just worked out that it's 23.5 kilojoules per mole. Now, we already said that it was exothermic. So we look at that temperature, it was a temperature rise, so it's exo. So that needs to be a negative delta H. So here I should have negative 23. Right, so we'll draw in the negative. There, negative 23.5 kilojoules per mole minus 1. Now, the question is giving you this next side. If you read, printed here on the bottom, we've got the second experiment written out, and they've told you it's plus 53.7. So I'm going to write it down. So that second reaction is going down here, and it's plus 53.7 kJ mole minus 1. So the overall reaction that you need to find out, so this is your last 2 marks, was delta HR, that delta H for the reaction. And to get delta HR, we're coming down this way, so that's minus 23.5, and we're going up this way, and because we're going up, that becomes minus 53.7. Sorry? Yes, 53.7. Okay, so there we go. We've got minus 23.5 plus minus 53.7. Put them together and you get minus 77.2 kilojoules per mole minus 1. Okay, thank you.